For being here. Let's get right to it. We're going to talk about responsible AI with a couple of folks that we have with us right now. We have Eric Boyd, Corporate Vice President of Microsoft Azure AI. Let me get that right, Azure AI. We have Rob Malseri, Distinguished Engineer at Cosign Data here at Microsoft, and Mira Lane, Partner Director, E&S here at Microsoft. Let's start with you, Eric. What are some of the new things that people should be looking for in Azure machine learning that they should be excited about?
Yeah, thanks for asking that, Seth. I mean, we've done a lot of work over the last, couple of years, really working with a lot of our customers. And one of the things we're finding is that as AI is moving out of the lab and into mainstream production, a lot more developers are needing help building AI responsibly, and they're looking for trusted tools and open source toolkits and things that will really help them. So we've been investing in offering toolkits that are easy to use and offer native integration with Azure Machine Learning, and they're just really seamless. We focus really on three key priorities. We really want to help customers understand, protect, and control their data and models. And so on the understand front, what we've done is we've offered capabilities powered by Interpret ML Toolkit. This is an open source toolkit that we developed with Microsoft Research and integrated deeply into Azure Machine Learning. And what it does is it helps developers understand why their models are predicting various things. The next is the Fair Learn Toolkit, which also open source, deeply integrated into Azure Machine Learning, and helps developers understand how to make sure their models are making fair predictions. And the third thing we announced is a differential privacy toolkit called White Noise, and it enables customers to build machine learned models using sensitive data while safeguarding the privacy of individuals. And all these capabilities can be accessed through Azure Machine Learning, and they're also available in open source on GitHub.
Now, I love the whole responsible AI, pivot, and I love the understand, protect, and control. Let's dive into the understand. So you mentioned a lot of products, but why don't you dive into each one of the things that are in Azure Machine Learning, what they do, and why they're important at a service level. And then we're going to get Rob to talk about how it works at the research level.
Yeah, I mean, what we're hearing from our customers is that they're really struggling to build responsible AI. So we want to get these tools into the hands of developers as quickly as possible. And we see a lot of need, but we know also that the area is not all that mature. And so we're really innovating as we go. And that's why we decided to put the core IP into open source to get the latest research in and iterate faster and really enable people to use it anywhere. And so, one of the first things is sort of the explainability side. I want to be able to tell a user, an executive, a regulator, why is my model making the prediction that it's making? And that's how Interpret ML really helps you. And then Fair Learn, it really helps you, why is my model predicting? Is it being fair in all the different types of decisions that it's making? And so, we can sort of talk through that a little bit more, but that's kind of how it's set up. And then the last is White Noise. Using differential privacy, it's really a complicated technology, but really bringing and injecting noise into the data to make it so that you can bring data together and keep it nice and protected.
So, do you have a demo for us to show us like how this stuff kind of works?
Sure. I mean, maybe I can share with you the Fair Learn toolkit. And so here, what you're seeing here on my screen is I'm in my Azure Machine Learning, homepage here, and I've got all the different work that I've done, and I've run this experiment previously. So I'll go to my Experiments tab and load up my previously run experiment. And here you can see that I've done a whole bunch of different runs on this particular experiment, but I'll go into the particular run. And this is a great thing about Azure Machine Learning is it gives you all the history, the details and everything. And so I can then, go into the snapshot of what I've done and actually see, the exact Jupyter notebook. So let me tell you what I was doing. I was building a model where I was trying to predict whether or not I should offer a loan to someone based on historical data and lots of different features from that. And this is an exact situation that we used with Ernst & Young as we were prototyping and learning about the Fair Learn toolkit. And, since I'm a pretty good data scientist, I want to make sure my model's not biased. So I'm going to go through and drop the sex and race categories to columns just to make sure that my model doesn't learn anything based on those. But the challenge that you run into is when you go and then build and look at your model is if I later I can use Fair Learn to go back and evaluate, hey, how did that actually perform against those different categories, the things that I didn't want it to learn about? And so by integrating FairLearn, you can see we've got the fairness directly into my run history here. And so as I go and click on the fairness there, what you can see is this dashboard, this FairLearn, which is integrated directly into your Jupyter Notebook and also directly integrated into Azure Machine Learning. And I can say, hey, I want to look at the sex and see how that affected the accuracy of my different models. And so what I have here is a graph where on one axis, the y-axis, I can see how much it's weighting sex as a factor. And on the x-axis, I can see overall how accurate it is. So this first model that I trained, the most accurate one, you can see it's 84% accurate. But if you look at it, you can see that for men, 25% of them basically get approved, whereas for women, it's only 7%. And so that's not the outcome that I'm looking for, even though that's not something that the model was trained on. So the next thing that I did is I did a grid search looking to vary some of the parameters in it. And that's what I'm looking at here is all of the different models that I trained. And so I can look for this one here. And here I can see the accuracy is 82%, which is very close to the 84% I had in the previous one. But here, as I look at the disparity in predictions, male approvals at 15%, females at 14.4, I'm much closer and much less, much more fair in using that approach. And so this toolkit's really powerful for people to give them, really all the controls that they need to look at their models and the work that they're doing and really make sure that they're making good and fair predictions.
And that's really cool because I think some of us as data scientists are like, if I just remove those columns, then maybe I have a fairer model. But those
I did
features,
my work. I dropped it, but it's still picked it up through other methods. And so that's why you have to go back and look and make sure you're doing it fairly.
So essentially the features leaked. Those features, gender and the other one, I don't remember, gender and race, they leaked in through the other, maybe by address or by something else. And you can't just take things out and expect your things to be fair. Is that right?
That's right. Exactly.
Well, that was awesome. Rob, let's get into the research behind some of this stuff. Let's talk about what you do, and then let's get into some of the stuff that you've been researching.
Sure. Thanks, Seth. So, I lead the Cosign Data Organization, which is a data science and engineering organization building core operating systems products for Microsoft. And that includes Windows, the operating systems that run in our cloud. And so, research that we've done builds on some of the things that are talked about. And I'll talk a little bit about interpretability, for example. The world is depending more and more on AI and machine learning systems for prediction and decision support. It's true in many industries beyond tech, including finance, healthcare, manufacturing, agriculture, and more. Those decisions and actions have higher stakes, and it becomes important that we can explain the reasons behind the decisions to meet our commitments to fairness, like Eric talked about, also reliability, safety, accountability, privacy, and security. One of the things I work on is Windows, and in that case, we're using machine learning to help assess the quality of the product and improve customer experiences. So, for example, with Windows updates, we train and use machine learning models to predict the impact of updates on system reliability and performance. And that might determine how quickly we update a customer's given device. We need to understand why behind these predictions to help engineers prioritize the work and determine best course of action to take. And this is where interpretability tools like Interpret ML come in, understanding the features that impact the model both globally and also for individual predictions and classifications. It's important at training time to build trust and for debugging, and also in production to understand how the model's performing, making decisions in the wild. Interpretability can help with detecting fairness issues, meeting regulatory compliance, and providing transparency in these applications.
Can you give us an example of something that interpretability would flag for you as a data scientist that would tell you to maybe go back and redo some of your model work or maybe even feature work?
Sure. Well, the key with a package like Interpret ML is it lets you bring together a variety of machine learning interpretability techniques, both the ability to train with glass box models, things that are transparent where you can see what's going on, as well as to explain black box systems. And so in this way, you can get a look into which features are having an impact on a given model, whether through feature importance, explaining explorations, or individual conditional expectations. It integrates best-of-breed methods like LIME and SHAP, as well as surrogate-type models to mimic the black box, and so forth.
So basically what you're doing is like, for example, I understand like glass box models because I can look at a decision tree and know what's happening, basically. But when we're looking at models such as like neural networks, how does something like InterpretML work around those kinds of black box models when we don't know what's actually happening to the features as they're going through the network?
Yeah, and this is where these methods like LIME and SHAP are used to basically to mimic the model, testing different inputs and looking at the outputs and identifying which features are having the most influence over the outcome, both globally and for an individual test case. And that helps the data scientist or machine learning engineer to debug what's happening in their model.
So let's talk about another thing. And I've always, look, I'm a data scientist at heart as well. And one of the things that I always struggle with is data, because it's a very personal thing, this data, and we don't want data to leak out, and we don't want people to learn stuff about people that they shouldn't. For example, doing testing on medical data is very, sensitive. Talk about white noise and how that actually helps protect that kind of thing. Rob.
Sure. So, White Noise project is set out to connect the theoretical work from the research community with practical lessons that we've learned from real-world deployments, and specifically applying differential privacy in a way that's more accessible for everyone. So, let me offer an example. One of the common things we do with data as data scientists is build dashboards and reports to help leaders keep track of things like roll-up metrics, count, sums, averages, descriptive statistics. Typically we aggregate data into large partitions, so any individual's data isn't revealed. But there are various re-identification and reconstructions in the literature that can operate on aggregates. Using differential privacy, it takes the guesswork out of the protection. We add a small amount of statistical noise that has negligible impact on overall accuracy at the aggregate, but we get to protect the individual data from any types of those kinds of attacks.
One of the questions I have about that is are we actually flipping actual data points? And then are we releasing the new noised up data set, or are we looking at flipping the data points and then revealing the aggregates? Do you see what I'm asking?
Well, differential privacy generally works in two different ways. There's something called local differential privacy, where the statistical noise is introduced at the individual data point level, and global differential privacy is done more at the aggregate level. The White Noise project delivers the global differential privacy, so you don't have to treat your data at collection time. You can treat it at query time. And the platform contains really three key parts to enable that. The core of White Noise is an open source library of differential privacy algorithms and implementations that come from mature research, as well as APIs for assessing things like privacy loss. The second part is an analysis graph for maintaining fine-grained control over the privacy budget, because when you introduce noise, the more queries you do across that data set, the more risk to attacking the budget is introduced. And then the third component is the interface, the systems interface with data. And that allows you to do SQL-like queries across common sources like PostgreSQL, SQL Server, Spark, Presto, CSV files, and so forth.
So that you mentioned a concept, this notion of a budget, which is kind of interesting because, if you introduce noise at a statistical level, you can subtract that noise out given enough queries. Tell us what it means about this budget, Rob.
Yeah, so when you set up the system, you can basically determine what the budget is going to be, and then you can monitor and maintain that budget and limit the number of queries that are happening over time to prevent, the ability to re-identify the data.
Well, this has been really cool, but now we're going to move on to Mira Lane, Partner Director, ENS at Microsoft. What does ENS actually mean? Why don't you describe what you do, my friend?
Sure, Seth. ENS stands for Ethics and Society, and my team cares about the effects of technology on people. We're a multidisciplinary group of product experts, designers, program managers, engineers, ethicists, philosophers, data scientists, and we're embedded in engineering. And we work with teams to guide our innovation towards ethical, responsible, and sustainable outcomes. And yes, there's a team like this in Microsoft. It's kind of amazing.
That is actually really cool. How is responsible AI making everything, our products, our company better? Let's start there.
Yeah, well, we think about ethics as innovation material. People care about privacy, they care about security, they care that what you build works for everyone, that it's fair. So there is a way to innovate in this space by thinking through the customer demands of responsibility along with the impacts of what you're building. Because we all recognize that our AI models are often part of a larger product offering and ecosystem. So there's a lot of ways that this innovation might manifest. It could include innovations in data collection methodologies or leveraging synthetics for model use and model training. This might also show up as new controls or tools that you build to guard against misuse or unintended consequences of your tech. It might also include more robust consent mechanisms or deeper thinking about different audiences like children and how they might use what you're building in a safe way. And so when we think about better products, we think of them as being more robust, that they're not limited by influences such as race, gender, age, or even changes to environmental conditions.
How is thinking about these things making products at Microsoft better? Or just Microsoft better in general?
Late last year, our team announced a new speech service capability, the ability to create branded voices using deep neural networks. And while there's beneficial applications to synthetic speech, we also recognize the potential for misuse and harm. You can easily imagine the impact of politically charged messages or hate speech and attacks on individuals and institutions through fake audio that's ascribed to real known people. But this also created a new attack vector as well for malicious actors to spoof a voice with synthetic audio to gain access. So this was definitely considered a thorny piece of technology. And what we did was we embarked on an extensive exercise to examine the benefits and whether we could create and release this in accordance to our AI principles. We did this by using some of our practices around bringing in diverse stakeholders, such as voice actors, so we could understand the impact to their jobs, by creating meaningful consent and transparent consent mechanisms, and importantly, anticipating the harm and unintended consequences. These are some of the practices that we use as part of our development of AI technologies. And to summarize, we did release this technology, but we limited availability through a gated service for a select set of trusted customers.
That's pretty amazing that we're that involved with that, and not only, and what's the word I'm looking for? That we want to make sure that we're doing things responsibly. Are other customers seeing the benefits of this as well?
Absolutely. So, customers, large and small, they're all looking for guidance on responsible AI, and they're holding us accountable to build responsible technology for them and even with them. So an example was an important factor for the BBC working with Microsoft, and this was because of our mutual approach to responsible AI. And, the BBC is one of the most trusted news organizations in the world. Customer data privacy is huge for them. It was a huge priority for them choosing a strong partner to help it build a voice assistant to deliver content to a diverse and underserved population. So a big motivating goal was reaching a broader, more global audience. And many of those were pre-literate. So voice offers a unique delivery and interaction experience and allows people to access news and information. And for the BBC, this broad and global reach means taking an inclusive approach to data collection and conversational design so it works for everyone. Seeing firsthand how Microsoft had developed these practices for anticipating and mitigating harms to how we bring in diverse stakeholders, and how we think about technology was a key factor in this collaboration.
Well, this is awesome. Let's take a forward look now. We'll start with you, Eric. What are we looking to do in the future with the services and products we offer for AI on Azure?
I mean, there's so much more that we can do in this space, particularly focusing on responsible AI products, right? Work that we've done around confidential machine learning. We're working with Microsoft Research to see are there ways that we can use special hardware enclaves, protected regions within the chips to be able to do machine learning there where the data gets, is encrypted everywhere except for this small place. Also, we're looking at things like homomorphic encryption. This is a technology where you can actually do machine learning on encrypted data. It's very interesting. Research area is extremely computationally expensive, but it just provides complete encryption all the way through the machine learning process. So a lot of things that we're looking at there. We're also looking at innovation to really help the end-to-end machine learning process. Everything from, how do you control your data and make sure that you know which models were built with which data, manage, governance capabilities and things like that. Things that, sound a little bit dry and boring, but as you're actually trying to use this stuff day in and day out is super important. So a whole bunch of new things coming down. Further down the line, we're looking at, robustness and adversarial machine learning is an area we'd like to explore. We see a lot more in reinforcement learning coming, a whole bunch of new areas that we're looking into. It's a really broad and fast-moving space.
This is cool. Rob, I want to talk to you. What's the future of research in responsible AI and machine learning?
Yeah, well, looking ahead, we expect things like Eric talked about interpretability, fairness, privacy-preserving technologies are going to be more important than ever as the stakes for these systems and individuals' data and associated risks just continue to go up. We're seeing increased adoption of differential privacy, and I talked about that at Microsoft and across the industry, but there's more room for improving the ease of application and integration of our tools. I think security is another important frontier. Machine learning systems can be vulnerable to specific kinds of attacks. Things like data poisoning, which is aimed at corrupting the predictive system by contaminating data in the training phase. These require new kinds of threat detection and mitigation. At Microsoft, we've been updating our security processes and our documentation to include these emerging threats, but that's just a start. Microsoft's a platform company, and along with our research team, the hope is to build more of these responsible AI capabilities that we talked about into more of our software and data platforms so that customers who build solutions also benefit and can better protect their customers' privacy.
That's really cool. Amira, we have about 2 minutes left. I want to make sure that people get a sense for how important it is to start thinking about this now, and what are some easy things organizations can do to implement AI responsibly?
This is a great question. So we should start by taking a human-centered approach. And what this means is that it's about understanding stakeholders and the value tensions among them. And when I say stakeholders, I mean people that will directly use your system, those who will indirectly interact with it, special populations like children who might be excluded from the design of your system, and also thinking about you and project sponsors whose views and values are unconsciously encoded into what you build. And next, we should exercise this muscle of learning how to look around corners and anticipate potential harms and impact. For example, how might your system reinforce stereotypes or biases, or how might the system deny someone access to critical services? And so as you start thinking about those, the next exercise is learning how to mitigate those potential harms. As part of Build, we're releasing some mechanisms, best practices, things we've learned through the development of AI technologies for bringing in diverse voices, as well as performing harms modeling for your systems. And when you do harms modeling, you think about this in the same way you would think about security threat modeling. So learning about, anticipating harms, thinking about harm in a really robust way. And, this is the future of innovation. This is how we expect modern product development to occur.
Well, this is really cool. We've got about 30 seconds left. Eric, where can people go to find out more about what we're doing on Azure with machine learning and AI?
I mean, you can always go to Azure Machine Learning on the Azure website on azure.com and just learn all about the different offerings that we have there. And so, there's a whole bunch of things that we're adding and innovating and doing each and every day. And so really look forward to working with everyone as they continue to work on this.
Awesome. Well, this has been amazing. Thank you so much for spending a little bit of time with us. We're going to send you off to one of our digital breakouts, C# today and tomorrow with Mads Torgersen. Remember to register for exclusive access to all of the concurrent breakouts happening right now. Back on the live desk after that. Stay with us.